All right, lesson 8, part 1. What about if we already have a log, but it's only on one side? Okay. Actually, it's very easy. It goes back to the very beginning. We're going to swish and flick. So when you have this situation here, we're going to swish and flick. 5 to the 3 equals 2x. Okay? And right here, remember first we need to get it by itself. So we add 2 to both sides. So we have log 3x minus 1 equals add 2 plus 1 is 3. This is a log base of 10. So 10 to the 3 equals 10 to the 3 equals the 3x minus 1. All right. So how do we do this? We condense to a single logarithm. Okay, we always want it by itself. Rewrite the equation like we just practiced and then solve. So 8 to the 4 thirds equals x minus 7. So we have a calculator. Let it do the heavy lifting. 8 to the power of 4 divided by 3. 16. Now, if you think about it, this means the cube root of 8. The cube root of 8 is 2, and then 2 to the 4th power is 16. If you can see it in your head, but even if you can, double check it in the calculator. Just make sure you didn't make a mistake. Maybe you did 2 cubed instead of 2 to the 4th. Equals x minus 7, and then it's just basic algebra. Add 7. X equals 23. And the beauty of this is you can plug it in, as always, with algebra. So 23 minus 7 is 16. 8 to the 4 thirds is 16. We're good to go. All right. Now, notice we have 2 logs, but they're on the same side. So that's where this comes in handy. We need to condense, which we've already done with the properties of logs. So remember, plus becomes times. Okay? So when I condense these, I'm only going to write log 6 once, but then I'm going to do 12 times x. Now let me make this very clear. Bells should be going off right now. The most common mistake, I'll put it in red, is people doing this. Combining to one log and writing 12 plus x. That's a big no-no. We're condensing. Plus becomes times. Okay? And then equals 2. And now we're going to swish and flick. 6 to the 2 equals 12x. Well, 6 to the 2 is 6 squared, which is 36. And we divide by 12. X is 3. All right. Remember, if we don't see a base, it's 10. So 10 to the 1 equals x plus 1. Swish and flick. 10 to the 1, which is just 10, equals x plus 1. So we just subtract 1, x equals 9. And again, we plugged it back in. 9 plus 1 is 10. 10 to the 1 is 10. It checks out. Now here, remember, we see ln. As soon as we see that, something should go off in your head. Wait a minute. That's a base of e. But we can still do this. Swish and flick. E to the 4th equals 4x minus 17. And remember, e to any number is a number. So e to the 4th power is 54.5981. Sorry, 82. 54.5982. equals 4x minus 17. So now we just add 17 to both sides. I'm having trouble writing evidently. Plus 17. Just go back to our calculator. Plus 17, not 14. Evidently I can't type either. And there's 71.5982. And then we just divide by 4. And then we get 17.8995. So that's going to do a lot of rounding. That's 17.9000, really. If you just put 17.9, that's fine. Okay, because the 5 rounds the 9 up, the 9 rounds the 9 up, the 9 rounds the 8 up to 9. All right, try to evaluate the following number in your calculator. So log of negative 20. Log of negative 20. No. ln of negative 5. No. Okay? A solution that causes a negative value in a logarithm is extraneous. You cannot have that. Okay? Because when you have this, b to the x equals a, squish and flick, b must be greater than 1. Okay? We cannot obtain a negative value for a. So always check for extraneous solutions. So here we have 10 is our base, swish and flick. 10 to the 1, or just 10, equals x squared plus 1. Subtract 1 from both sides, we get x squared equals 9. Square root both sides, and we get x equals 3 and negative 3. But we have to check the numbers. Okay? So if we plug in 3 right here, we get 3 squared is 9. Okay? 3 squared is 9, plus 1 is 10. 10 to the 1 is 10, check. Negative 3 squared is also 9, plus 1 is 10, so we're good to go. Both answers are correct. Now here's what happens. You can't get lazy and not check, because some people will go, hey, they said no negative values, so that must be wrong. Nope. It's getting plugged in here and you got to check it. So since it's being squared, it turns it positive, which is the same as 3 squared. So it works out. It's okay. 2 to the 3. 2 to the third power equals 2x plus 10. 2 to the third power is 8. Plus 10. Subtract 10. We get negative 2. I don't know why I wrote an x. Equals 2x. Excuse me. Divide by 2. X equals negative 1. Evidently I have a frog in my throat. So now we got x equals negative 1. We're going to plug this in here and check it. 2 times negative 1 is negative 2. 10 minus 2 is 8. 2 to the third power is 8, so that checks out. Moving on. We have a plus. Remember, that's going to turn into times. I'm going to condense and write log 6 one time. And then I'm going to take this times this. X times x plus 1 equals 1. Swish and flick. 6 to the first power, which is just 6, equals x times x plus 1. If you want to save a step, you can just write x squared plus x and distribute it now. But then we're going to move this back over, so we're equal to 0, so we can factor x squared plus x minus 6. I almost wrote equals 0 again. Habit to put it on the right side. And I'm just going to factor. I need two numbers that multiply to give me 6. that differ by 1. Well, that's 3 and 2. I want more positives than negatives. And then when I solve, I get -3 and +2. So when I check this, I'm going to plug in the -3, log 6 of -3. And at this point, boom, I'm done. Cannot have a negative there. So this one is extraneous. All right. I can, though, plug in the 2. Log 6 of 2, that looks good, plus log 6 of 2 plus 1, which is 3, equals 1. And if I plug that in the calculator, if I wanted to verify any further, it works out. We're good to go.